Hello and welcome here at BASF booth of K-Fair 2019. We're here with the second live talk of today, which will also be the unfortunately last live talk of today, short program. We're going to talk about applications made from TPU, and to discuss this topic, I have a guest here who is Moritz Kügler from EOS GmbH and Anke Johannes from 3D Printing Solutions of BASF. And yeah, welcome to both of you.
Thank you.
Thank you very much.
Yeah.
First question to you is, what exactly is laser sintering and how are we using that?
Sure, thanks for the question. So laser sintering is a method of 3D printing. 3D printing has been hyped in the last years, of course, but now we actually come to industrial manufacturing with it. So of course there are different methods with 3D printing, especially in plastics. And laser sintering stands out with a very high quality of parts that can actually be used in industrial applications. So the difference is in the manufacturing process that we use a very, very fine powder, a very special powder that is applied in layers of between 60 to 180 microns and then gets heated just below the melting temperature of the powder. And then as it's not melted yet, a laser exposes exactly these areas of the powder bed where the parts are created, basically, where the powder should melt to create the parts. And this is the main difference to other technologies because we have this powder bed. In general, of course, the productivity with that is quite high, but of course the investment is also a little higher compared to other technologies. So it's not a usual process that you use at home, but rather something for industrial applications.
Okay, and how did the two of you get together to work on this?
I think both of us was looking for a partner. As you know, we are very strong as BASF in TPU development, and there was like no product available in the market. And so we were very happy when EOS came to us, or we came to you, I don't remember, that we start a joint project to develop a material for laser sintering.
Yeah, we were really looking for a partner. I mean, there are some TPE materials in the market, but of course we are looking for strong partners who have, of course, a very good track record with TPUs, and BASF is the choice of partners I think you can have in the market. So we're very glad that this JDA, this joint development, actually happened, and I think we can be very proud of the product that we developed.
And what I understood from the two of you when we talked before this, the TPU is actually quite special, as there is not much that can be compared to it with regards to the performance when actually doing a 3D printing of parts with it.
Yeah, that is correct. Of course, for the method that we're using, laser sintering, we have very high requirements to the powder that is needed, and BASF was able to deliver that quality, which is very great.
Yes, and for us as a material producer, it really makes a difference if you develop a material without a partner from as a machine producer, because it was very, very good when we developed the powder. It could be tested on the EOS machine, and so they could adjust the parameter and we could adjust the parameters of the powder. And so, I mean, the target of both of us is to have a very high quality for our customers and also consistency of quality. So, and I think that was also very important because customers, if they get a new batch, they don't want to play around with the powder or the parameters, they just want to press the button. And so I think we achieved this together with EOS, that we have a very high quality powder.
So it just works, and it works in a variety of things. So I could ask you what to do with it now, or we could just have a look at what we already see here on this table. And yeah. Would you just point something out to us and explain what it is?
Yes, we brought a lot of samples because we are very enthusiastic about it.
Exactly, yeah.
So Moritz brought some different lattice structures, and unfortunately our viewers cannot touch it, but you see already that it feels very, very different. It's very flexible, and in comparison to this, maybe Moritz, you can take one which is a little bit more stronger.
Exactly, yeah. So the beauty of 3D printing, and especially with these high quality powders, is that you can adjust the properties. So I think today it's mainly known that a TPU has a certain shore hardness, right? But with 3D printing, we have the possibility, by adapting the structures, for example, on this part, by making the lattice structure a little thicker, we actually get very hard damping properties. And when the lattice structure is thinner, we get a very soft material that's easy to bend and easy to work with. So you can, by design, adjust the characteristics of the material, which I think is a novum as well also for BASF to work with.
Yeah, that's pretty exciting. I was actually able to get a look and feel before, and I think everyone's invited after this to actually come up here and also get a feel of what it's like, because then you get a better idea of what Moritz was just talking about, because on the one side it feels very structurally strong, and on the other side it's very soft. Very interesting. And do we want to talk about the masks still? Because that's something
Of course. Because we are very, very happy to have a very nice person who uses this mask. I'm not allowed to wear it because it's a unique product for Crow, which at least German listeners know very well. We printed it for him and he's already wearing it. And he already posted it on LinkedIn, and he also colored it. So it's not a white mask that he uses, but he uses the well-known Panda optic.
Yeah, and I think it's a very good example, because this really shows also what you can do in terms of individualization, because this mask is perfectly adapted to his face features, basically, so it fits perfectly. And this is just one of the benefits you can have with 3D printing.
Yes, and it has a very good surface, which is very important also when you wear it. So it has a very good touch and feel, and as you can see again, it's very flexible.
It's very thin also, while still being durable. It's interesting.
Definitely, this is one of the key features of laser sintering, that you have very thin material, very flexible properties, but still durable. As you already said, it's really good, and that's why we think beyond, of course, these very nice and colorful application, we also see huge potential in, for example, the automotive market, where these properties are, of course, needed.
And now when we're talking about application potential, when does this become available to broader scale on a commercial level?
So we have really good news, I would say.
Exactly,
so,
yeah.
Moritz,
so,
please.
I mean, you see it works already, so we are very proud of what we achieved so far. And on the Formnext, so next month, Formnext 2019 in Frankfurt, we will officially launch the product and make it available from there on for all of our customers.
That sounds great. Exciting news here today. And next steps for the two of you?
I definitely think we will come up with new material. So I think we will continue our very good cooperation. Yep. And let's see what kind of material it will be. Maybe a more flexible even TPU, or maybe a high industrial material. I think always are open.
Definitely. I mean, this is just the first step in the cooperation or the collaboration, I would say. So we are very proud that we have a first product yet. But of course, we're looking... BASF has a huge portfolio of materials, and of course we're looking into others as well.
So many new things to come. Thank you both for being here. Thank you, Moritz. Thank you, Anke.
Thanks for the opportunity.
Thanks everyone for watching. And if anyone wants to give it a look and feel, as I said, come up to the stage,
but
try
it.
But don't steal it, yes. Thank you.
Thanks.